All right, so solving polynomial equations by graphing. We've actually done this because we've graphed quadratic equations. Okay, and quadratics are polynomials. So if you go back to that time, how do we know what the solution is to a quadratic equation if we graph it? Where it crosses the x-axis. Okay, so essentially that's what we're going to do again. It's just that instead of parabolas, we're going to have different shapes. Okay, so, but what they're saying here in this learn section is that just like with quadratics, it's easier to graph this after you get it set equal to 0. Okay, and now the zeros are important because of the relationship of multiplication. Okay, we kind of talked about that with quadratics. And also, if you're looking for the solutions, usually your graphing calculator starts with something that looks like that. Okay, so we're going to talk about two different ways to do these. We've talked about these before, but the first way is, okay, look, we want all of this on one side of the equation. Okay, and so then move things over, subtract the x, subtract the 6, and then you would have this function. Then you throw it in the graph, and just like before, you're just looking for where it crosses the x-axis. Fair enough? Fair enough. All right, so we're going to do this in a couple of different ways, and one of them is, well, we're going to do this with your graphing calculator, and then I'm going to say something about the graphing calculator in a second. All right, so we're just going to follow this idea of getting it set equal to 0. Here's our original. And so what we're going to want to do is add 4x cubed to the other side. They've rearranged it into standard form, which means that the exponents get smaller left to right. And now it is set equal to 0. And again, once you set it equal to 0 and you're going to graph it, you're saying, I want to find where it's crossing the x-axis. And so this related function is just exactly what we have. Now, the book, for whatever reason, talks about this, what I'm about to say, in the last section. I think it's in this chapter. I'm not sure why they don't talk about it already. But we are looking for places that it crosses the x-axis. And how many places are we looking for? Well, the biggest exponent in your polynomial is the potential amount of solutions. So in this one, we should be looking for 4. That does not mean that you're always going to find that many. And in fact, in this case, you're not going to find that many. But that is something to keep in mind. So go to y equals, put in this x to the 4th plus 4x cubed, and then hit graph. And hopefully it looks like it does in the picture here. Does everyone have basically that picture? Okay, and if you reset your calculator, you should have that. All right. So now I just said that we're looking for 4, but this one only has 2. Now, it helps to know what the shapes are. Okay, so I know this is x to the 4th. I know the leading coefficient is positive, so it's going to make some kind of W. But, right, it's only intersecting the x-axis twice. All right, so now the rest of this is getting us to use the calculator to solve it. Since we got it set equal to 0, that means we're looking for where it crosses the x-axis. And so because of that, from the graph screen, go to the calc menu, and the calc menu should be above the trace. So you're doing second calc, basically. And then it gives you a menu, and since we are looking for the zeros, go down to 0 and hit enter. Okay, so now, once you hit enter, it goes back to the graph, and then it should have a question at the bottom. And do you see the left bound? Okay? So then I think that you guys start right here. Is that right? Is that where your cursor is?
Yeah.
Okay, so then let's just do the left one first. And so what the calculator is asking you to do is to get just left of the 0. So you scroll until you get just left of the 0, which will be right above the x-axis. Now the closer you get, the better. But as you move, you see it jumps really far. Okay, so if you wanted to get closer, you'd have to zoom in. But we're not worried about that right now. I just want you to know how to do it. So it does have to be above the x-axis, and that would count as left. Once you get there, hit enter. And then it should ask you another question, right bound. Okay, so then you have to move the cursor right of the 0, which in this case will be right below the x-axis. You hit enter again, and then they will say guess. And you say yes by hitting enter. And then down at the bottom, it'll give you like a coordinate. And what is the x value of that coordinate?
Negative 3.21.
Okay, now, everyone should have something very, very close to negative 3.21. If you don't have negative 3.21 exactly, but it's very, very close, then everything is fine. Okay, because the accuracy depends on how zoomed out we are. So if you reset it, everyone should probably just have negative 3.21. Okay, but as you go forward, understand that maybe it's going to be a little bit different because it's kind of just guessing in a way. All right, so then to do the other one, of course, we have 2. You got to go through the process again. So go back to the calc menu, go down to 0. Again, they drop you probably in the same place, or no, they put you back on the left now. Okay, so we're going through the left bound again. So now you got to scroll all the way, right, until you're left of the 0, which in this case now will be below the x-axis. You hit enter. It's asking you for the right bound, so you keep going right until you get just a little bit above. That would count as right. You hit enter, and it says guess. And so then you hit enter again, and then you get what?
0.84.
0.84. All right, is everyone getting these or something very, very close? All right, now, I don't mind if you guys use Desmos for quizzes and homework and stuff like that. So there is no argument whether Desmos is easier than that. I mean, it's clearly easier than that, right? Because you just go on there and you click the 2 places and it tells you what they are. But you can't use Desmos in all math classes. You can't use Desmos on the ACT. So this is how you would, and you can use these all the time for any class or ACT or anything like that. So that's why we're going through this. Is that okay? Would you like to do the check, or are we okay? Let's do the check. Okay. So then we're going to do it the same way that we just did, because our next example we'll do it the other option. All right. So we got to get everything on one side. How do you want to do that? Like, which side are we moving stuff to?
It doesn't matter, does it?
No, it does not matter. No, it does not matter. So I just want to do it all the same. So which side do you want to go to?
Right side.
Right side, okay. So I would choose that also just because the x to the 4th is already positive over there. So then how are we going to do that?
Subtract a half, x to the 4th.
Oh, I thought you were going to the right side.
Oh, yeah. Subtract 4x to the 2nd.
Okay, so subtract 4x to the 2nd. Well, it would just be minus 4x squared, right?
Oh.
Because they're not like terms.
Oh, yeah.
Okay, now what?
And then subtract the x.
All right, so now we have it set equal to 0. Okay, now what?
Okay,
All right, go to y equals, put that thing in the calculator. What are we looking for?
zeros.
Yeah, so where it crosses the x-axis. I don't know the answer, so I'm going to check you. Who picked this one? Nice. So you have it graphed. How many places is it crossing?
4.
Yeah, it's crossing 4 sides. So we got to go through this cycle 4 times, right? So, how about this? Someone do the left. Who's doing the very left one? So we don't have to spend. All right. Ashton's doing the very left one. Who's doing the second from the left? When too many people raise their hand, it makes it difficult for me because then I got to choose, and I don't want to make someone feel bad that I didn't choose them. So I can, maybe just one person raise their hand. How about that? Ashton, when you get it, let me know.
Yes, sir.
Did you say you needed left or right?
So second from the left. You do second from the left.
Yeah.
Okay, thank you. We got 2 more. I got the 2 negatives covered. Yeah, we got
Negative 2.7.
negative 2.7. Okay, good. Looks about right.
And then negative 0.60.
Oh, you got the next one? Okay, so negative 0.60. All right, we need 2 more.
I'll just do the positives then.
Okay, positive, thank you.
I know the other one was 0.30. And then, I don't know the way.
The other, okay.
The other middle one.
0.39.
0.39, okay. And then 1 more.
I've already had it. If my cursor could move a little faster.
You got a slow cursor.
2.9.
Sounds like a personal problem. All right, so hopefully you got something very close to those. Those look pretty good. All right, so is that okay? Again, we're solving these by graphing. One of your options is to get everything set on one side, set equal to 0. Look for the places that crosses the x-axis. Okay? Again, Desmos is much quicker. There's no argument about that. We've captured some emperor penguins and we have put them in a life of servitude. For an exhibit with 6 or fewer emperor penguins, the pool must have a depth of at least 4 feet and a volume of at least 1,620 gallons, which is about 217 cubic feet per bird. All right, so that's important. We need at least 217 cubic feet per bird. A zoo has 5 emperor penguins. What should the dimensions of the pool shown at the right be to meet the minimum requirements? Okay, so this is this is basic shape that they wanted. Okay, but we have some minimum requirements. All right, and we're asked to write a polynomial equation first. So use the formula for the volume of a rectangular prism right here, length times width times height. To write a polynomial equation that represents the volume of the pool, let h represent the depth of the pool. All right. Since the minimum required volume of the pool is what per penguin?
4 feet.
No, we're talking about volume though. 217 cubic feet. Okay, the 4 was the height. It has to be at least 4. Or, since we don't have just 1 penguin, how do we find how much we need for 5 penguins? Yeah, 217 times 5, and what do we get when we do that?
1,085.
1,085 cubic feet. That's the minimum. So that's how much we need for our 5 penguins. The equation that represents the volume of the pool is where's this? What is this here? What is it? Well, okay, so I mean, what's that stuff I underlined though? Where's that from? Length times width times height, right? Okay, and so then what does it have to equal?
It has to equal 1,085.
Yeah, because we got 5 penguins, so we got to get in there 1,085. All right, so then they gave us this equation, and all we're doing is solving this equation. Okay, so please, take your time when you do these. Don't over distribute. I would do this by foiling here, simplifying, and then distribute the 2x. Okay, I'm not sure how they did it, but we can see what they did. Right, they did some kind of foiling / distributing. Anyway, they get it down to 10x squared minus 4x plus 15x minus 6. We combine some like terms to get 10x squared plus 11x minus 6. Now we have to distribute the 2x to everything. So finally we have 20x squared plus 22, x cubed, that should be an x cubed, sorry. 22x squared minus 12x. And that equals our volume. So is this okay? We see where this comes from? So the volume of the pool is basically this function right here. All right, now, what they're saying now is, all right, we want to solve this, but instead of subtracting the 1,085 to the other side, which you could totally do, and then look for the zeros. Okay, we can also solve this by graphing each side of the equation. You can do this in any equation that you want. Okay, so we can graph the left-hand side, which in this case is 20x cubed plus 22x squared minus 12x. Put that in y1. So go ahead and put that in y1. And then we're going to also graph the horizontal line y equals 1,085. Again, you can do this in any equation. I'm going to tell you the pitfall of doing it this way here in a second. But this is your other option. Again, this works for any equation. Now, when you graph both of those, I doubt that you have this picture. Why do we not have that picture? Was that? Yeah, so they got a different setting. So here's one of the things about this. You got to be able to figure out where to look. Because if we're looking for the intersection and it's not on your screen, the calculator won't do what you want it to do. So we need to adjust our window. I would not zoom in and zoom out because this is kind of a big number and it might be tough to see what's going on. You can if you need to, right? But we can just change our Y max to something that fits. What would fit? So we're going to Y max, or I'm sorry, to the window. And then we're going to change Y max. What should we change the Y max to?
I'd say probably 1,100.
Yeah, 1,100 would be safe because you want to see the intersection. And we have this value, Y equaling 1,085. So we got to get that on the screen somewhere. Mm-hmm. Again, I would always go a little bit above. So 1,100 seems perfect to me. So change your Y max to 1,100. And then when you graph it, you should see the intersection pretty easily.
The very bottom, like that is.
What's that?
It's at the very bottom. The x-axis is at the very bottom, like that one is up there.
Yeah, so they must have changed their x-min a little bit. So you need to see the intersection, and as long as you can see the intersection, then it's pretty much okay. All right, so we're going to use the calc menu again. So go, it's above trace, so second trace or calc, whatever. And then go to the intersection this time. We're not looking for zeros anymore. We want the intersection. And this is much easier to do because now the questions that it's asking you is first curve. And so if you only have 2 on there, you don't really have to worry about it. because you're only getting 2 options anyway. So first curve question, enter. Then it jumps you to the other line, second curve question, enter. Guess question, enter. And this should drop the cursor right on the intersection point. And then what is the x value? The x value is what we need. What is the x value when you do that? 3.5. Now, someone in the other class got 3.4. Does anyone have anything besides 3.5? Okay. All right, so 3.5. That's our x value. Remember what you're looking for. We're not looking for x on this. We want the dimensions of our cage, of our penguin prism. All right, so then we're substituting 3.5 in for x for our length, and we get what? $10. We put it in for our width and get what is it? 15.5. And then finally our depth will be 7 feet. Is that okay? So you don't, like, it doesn't matter which way you do it. Now, what I'm going to say is on number 3, all you guys got to do, like, the rest of the time is yours to get this done, 1 to 15 odd. On number 3, if you do it this way, where you're not finding the zeros, the third intersection point is really, really far up. So you may look at this when you're doing them and say, oh, there's only 2. But there is actually 3 on that, so just be careful to look for as many as you need. Is that okay?